The problem name is number of islands. So this problem is previously solved using BFS and DFS. Now in this problem we are going to solve this using union find algorithm. Here in the related topics you can see union find. So this depth first search and the breadth first search is already solved, and now we will be solving union find. So in the given problem we need to find the number of islands. So 1 is representing the land and 0 is representing the water. So you need to find the connected component. This is actually finding a number of connected components. Instead they replaced with islands. So you need to find the vertical you need to find the connecting adjacent lands horizontally or vertically. So you need to find that type of islands. So here only one island is there, and here we can see three islands. One for this, and one second one for this, and third one for this island. So now in the union find, why how we came to know that it is a union find? Let us see. Now what is the what is the starting land? It will be 0 0. So for this 0 0, what are its neighbors? Its neighbors are 1 comma 0 and 0 comma 1. So these are the two neighbors for 0 comma 0. So in union find, what we do? So if there is a edge from U to V, and if they don't belong to any parent, or else if the parent of these are different, then we will make them as union U to V, or we can also make it as like this. So suppose these two belongs to some other parent, like here let us say, suppose this is for this is the parent of U, and if suppose this is the parent of V, if this is the parent of V, then we these two parents are different, right? So we need to make them combined, either by making this as parent or else this as parent. For now I am making V's parent as parent of U's parent. So I am making parent of like this. So in this way this becomes the root, so that it will look like this. So this is for a U part, and this is for V's part. Here we will be using path compression and rank optimization methods, so that this union find algorithm can be much more reduced with the time complexity. So here first of all we will make the we need to make the islands, right? So first of all we will be starting from the 0 comma 0. Since this is a land, I will make its adjacent as union. So here we can see for 0 0, 1 comma 0 is the neighbor, and 0 comma 1 is the neighbor. So I make 0 comma 0 as the root, and 1 comma 0 and 0 comma 1 are the neighbors. So these become the child for this 0 comma 0. Now again I come to here, and I come to 0 comma 1. Now for the 0 comma 1, what will be the neighbors? The neighbors will be 0 comma 0 and 1 comma 1. since 0 comma 0 is already parent of 0 comma 1, we ignore this 0 comma 0 and we only keep 1 comma 1 as the child of 0 comma 1. So this become the child of 0 comma 1. In this way we have found one island. uh, Here next we will traverse like this, and here also we can see 1 comma 0 has the land. Now it has what are its neighbors? Its neighbors are 0 comma 0 and 1 comma 1. These are already child of child of 0 comma 1, and 0 comma 0 is already a parent, so we should ignore this 1 comma 0. And next land that we can see is 1 comma 1. Since 1 comma 1 is already visited, and all its neighbors are already parent or a child of some other nodes. We can see here 1 comma 0 is the child of 0 comma 0, so we ignore 1 comma 0. And 0 comma 1, this is also a child of 0 comma 0, so we ignore making these neighbors as child node for this node. So this is 1 comma 1 is acting as a parent, and there is no other child nodes. In this way we found one island, and we traverse in this way, and we found next land here. So we check whether there are any adjacent nodes that are lands. There are no any adjacent nodes that are lands, so we found only one land here. And next we traverse in this way till here, and we found the next land here. Now what are its neighbors? Up, so we need to traverse in horizontally vertically manner, right? So its neighbors are 3 comma 4, which containing the land. We only need to consider only the lands, no, not water. So I only consider this 3 comma 4. So this becomes the child of this land. In this way we are making island 3. So in the union find, instead of using two indexes, it is better to use single index, right? So for that purpose we need to make this two in I comma j to be some unique identifier. For that, here we can see if we have I comma j, we can make it unique by using this formula. This one will be the column length, and I into column plus j. How this is becoming unique, here we can see at 0 comma 0, 0 into 5 plus 0 is 0, and at 0 comma 1, 0 into 5 plus 1. So this is the column length, and this is the I that we are at ith row, and 1 will be the jth column. So here we got 1, and here I into 0 into column length, which is 5 plus j, it is 2. In this way we are going to do for every ith row and jth column. Here let us suppose here here I is 2, and column length is always 5, and plus the 0, this is jth column. So in this way, for the first column, for the second column, for the third column, for the fourth column, we will generate like this. Here we can see some numbers are in increasing order. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So in this way we can see that there is a uniqueness of I comma j. So we will use this uniqueness in order to generate in order to use in the union find. So we will be using a single number unique identifier here instead of using dual digit. Like instead of using I and j, I will be using unique identifier. Here, how we can generate unique identifier? Let us see. Here, previously 0, comma 0 is the land that we have seen previously. Now for this 0, comma 0, what is the unique identifier? It is 0. And now what are its neighbors? Its neighbors are 1, comma 0. So for 1, comma 0, what is the ID? It is 5. Here we can see it is 5. And for 0, comma 1, 0, comma 1 is a neighbor of 0, comma 0. So which is containing land. So 0, comma for 0, comma 1, what is the unique identifier? It is 1. So it is now 1. And we come to 0, comma 1. So for 0, comma 1, what are the neighbors that were unvisited? So 1, comma 1 is the neighbor that is unvisited. So for 1, comma 1, what is the unique identifier? It is 6. It is 6. Now this has now we go to 1, comma 0. So for 1, comma 0, all its neighbors are visited, and for 1, comma 1, all its neighbors are a part of some other child, or they are part of parent. So they are already visited. Um, so this become one island. And next we come to here for 2, comma 2. What is the unique identifier? 2 into column length, which is 5 plus 2. So 12 is the 12 is the second island. And for third island, we can see here 3, comma 3 is the root. So 3, comma 3 is 3 into length of the column, which is 5 plus 3. So 18 is the will be acting as 3, comma 3. Instead of 3, comma 3, I have written unique identifier. And next we go to 3, comma 4. Since this is the neighbor of 3, comma 3, we will be using it as child here. So for 3, comma 4, what is the uh, so for 3, comma 4, what is the unique identifier? It is 19. So in this way we can find there are 3 islands. But here we will be using count to count the number of lands that were before this construction. We will be using a count to keep the count of number of lands that we are having. So here how many lands are there? 1, 2, 3, 4, 5, 6, 7. So there are 7 lands here. Initially the before constructing the union find, so we will count the number of lands in the grid. So we have 7 lands. Now uh, during construction, when we keep when we keep the arrow union find, we will reduce one count. So here we can see how many arrows are there? 1, 2, here 1, here 2, and here 3, and here there is no arrow. And here we can see here the arrow count is 4. So 7 minus 4 will give us the answer. So these 4 arrows are these 4 when we subtract the 7 minus 4, we get the answer. So this 4 is the arrows count that we minus from the lands. So in that way we are going to generate this answer. Now we need to apply the union find algorithm. So in the union find, how we can do union? We can do union by finding the id of by finding the id of suppose this is u and this is v. So we can find the id one now. This one will be acting as, so we can find the parent of the root. Suppose this is one path, so we'll find the root parent of u. So find parent, find u's parent, and find v's parent, find v's parent. And if rank of, suppose if id1 is not parent 1 is not is equal to uh, parent 1, so u and v are not belongs to the same set, then we will do the union, right? So here we can use rank, union by rank and path compression in order to reduce the complexity. So in that way we will be solving this in O of 1 for finding the parent, and by using the rank this will be solved in O of 1. So mm, if the rank of id1 is less than rank of id2, that means left rank left side rank is less than right side rank. That means if suppose this is in the left side has three elements, suppose the id1 has three elements, and for id2 there are four elements. So we can make a link, we can make the parent of id1 is equal to the id2. So we make parent of id1 is equal to id2. Else if rank of id1 is greater than id2, suppose this is the parent of u and this is the parent of v, then we make the link with the parent, we make the link with id, parent of id2 will become the id1. So we make link like this, rank of id2, if that is the greater, then I will make parent of id2 will become the id1. So suppose if both lengths are same, like um, suppose if both lengths are same, both ranks are same, that means both sides containing so both sides containing the same elements, both sides containing the same elements, then we directly make one of the parent as, suppose I make the parent of id1 as id2, and I need to increment it, right? After making the parent of id1, how it will be, it will be like this, right? So now the rank of id1, now the rank of id1 is going to get incremented. So this will be for the union. Now for finding whether the, so for finding the parent, so for finding the parent, what it is going to take, it is going to take the number and if that number is same is equal to parent of that number, then I need to return the same number. If that is not case, return parent of number is equal to find of parent of number. So what this will do, suppose there is a path like this, and suppose this is 1 2 3. Suppose we need to find the parent of 3. What we will be doing, we will be searching whether the number is equal to the same parent. Suppose there is a parent array like this. uh, Here 1 2 3. For 3 the parent is 2, for 2 the parent is 1, for 1 the parent is 1 itself. Suppose we are searching for parent of 3, right? So next, if 3 is not is equal to 2, right? So we go to next iteration and we find parent of 3. Next 2 comes, 2 is not is equal to 1, right? So next again goes to 1. So 1 will be equal to 1 is equal to 1. So then we will be returning 1, and in this way the 1 is returned to the parent for the parent. So 1 will be returned for the parent of 3. Now while coming back, we will update the parent of all its childs. So for 2, what is the parent? 1. For 3, we also make the parent as 1. So in this way we just make this searching of the parent, or searching the parent in O of one way. So we make it in a single way. Single O of one time complexity will be used for finding. So let us implement, and so if we make the union, suppose if we make the union, what I have said before, to in order to keep the count of these arrows, this arrow implies that we are making a union. So in that case, what I will do, when I am making a union, I will reduce the count. So in that way, at the final we will be just printing the count of the union, count of the count of the islands. So now let us implement. Now let us write the code for this using union find. So I will define a separate class for using union find, and all methods will be in the public, So what methods we require? We require find method. It takes the number, and next what method we require? We require union uv. Union is a default method. I will use union set int u comma int v. We need to make this uv as union. Now what I require? I require the parent, right? So I require the parent array, the parent, and I require the rank, and I need to keep the count of lands. Now I write the constructor union find. What this union find constructor will take? It will take the grid. It will take the grid and enter rows. Rows is equal to grid dot size into columns. So here what is the column length? Column length will be 1. So we can write grid of 0 dot size. So for die is equal to 0, I less than rows, I plus plus, j is equal to 0, j less than calls j plus plus. Here if the grid is the grid of ij is double is equal to 1, means that it is a land. So we need to count initially the count of lands will be 0 and parent dot size will be of length rows star columns. So the it will be n into m. So parent dot size will be n and we need to resize, right? So resize and rank dot resize will be of type length n and rank of everything will be 0. And for the parent we need to use for loop to make instead of using for loop I will okay, parent of everything will be same as the id we are generating, right? Here what will be the id, that formula we are using, I into call plus j. In this way we will initialize the parent will with the same value for 0 1 2. So count of the lands is going to get incremented, and we found the land and the id that we generate is I star calls plus j. This will give the unique id and parent of id is same as id. So now we have counted the number of lands that are in the grid, and we take the id in the iteration and make the parent as id is equal to the same id. And here so in the find method we will write if parent of same number is equal to the same, then we'll return number itself. If that is not the case, parent of number will be become the parent of number. So in this way, so the number should be numbers. So this number should always be positive, and we use the path compression. Here we use path compression and here I will find the ID1, find. So this is for finding set1, find u, and find set2 is equal to find of v. So if these both if sets are different, sets are different, if the sets are different, I need to check the rank of S1. Should if that is less than rank of S2, I need to make update the parent of here. Here we can see here we make the parent of S1 is equal to S2 since S1 is less than S2. Else, if rank of S1 is greater than rank of S2, then we update the parent of S2 is equal to S1. If both ranks are same, then I need to make parent of S1 is equal to S2 and update the rank of S1 since here here I have explained, right? Here parent of S1 is going to get one extra node that is going to increment. So parent of S1 is going to get incremented. Now we have return union set and the find methods, and we have counted the lands initially and marked the parent with the same ID itself, and we will write the normal function. Here we require these 4 directions, so I will be using these di and dj. This will tell the directions for moving up, right, down and left. And let us take the let me use the previous n and m and so I will use the previous code here. This code is actually used before for using BFS and DFS approaches. Now I will use it for union find. So we will initialize the union find u f with initially passing grid. Now we check whether this is a land and compute the ID1, that is I star. No. Here we should here what I have done. Here we can see that we are generating ID of its neighbors and also for the current land that we are standing. So this one is the checking the whether the current ij is the land, and we mark its neighbors when those are also land. So we union them, we make union when the neighbors are also lands. So I am moving in the 4 directions, that is up, right, down, left. So in the question we can see we should move in vertically, horizontally. So I have used this two arrays for moving in the directions, and the new directions will be x I plus di of I, and y will be j plus dj of j. Now we check whether these are valid. X and y is valid, x comma y comma n comma m, and if suppose this is a valid, and if this neighbor also is a land, and if the neighbor is also a land, then I will compute the id1, which is I star calls plus j. This is for outer, that is a root, and this is for computing the child. It is x star calls plus y. So in this way we are going to union them. Uf dot, what we have written union set function in order to make the union id1 id2. So in this way we make the union, and at the last what we going to return, uf dot count of lands. So in order to access this count of lands, this count of lands should be kept outside, like this should be made as public, and these are private. Count of lands is initially 0, and we incremented the counts, right? So in here during union I have to decrement the count of lands should be decremented by when the union case occurs. So in this case the count of lands is decremented. Now we will be at the final, we will return the count of lands. So this is the code. Now let us check is there any syntax errors or logical errors that I have written. Here the function that was initially given, and I have computed, I have take the size as n, row size as n and columns as m, and I have initialized union find uf of by passing grid. So here what it will do, it will initialize the count of lands as 0 and rows columns, and we take the size of the parent and rank as n into m, that is rows into columns, number of rows into number of columns, and I will be traversing the grid, and if that is a land I increment the count of lands, and I compute the id, that is going to make the parent of id is equal to id. So next the find function, it will tell the parent of the current element, and this should be a positive integer, and we check whether the number is equal to the parent number. That means there is no parent for this, so we return that number and make the call recursively by knowing the parent of the number, and we path compress the while coming back. So in the union set we pass id1 and id2. Here we pass id1 and id2, and here we check the rank of set1 and rank of set2. If the rank of set1 is less than, means in the left side, and in the set 1 we have less elements, so we make parent of s1 is equal to s2. The rank of set 1 is greater than rank of set 2. We make the parent of s2 is equal to s1. This doesn't change the rank of both sets because we assign the lowest to the highest. Here the both ranks are same, so we make parent of s1 is equal to s2, and we increment the rank of s1. Why? Because here one more extra node will be there when we add the left side, right side set 1. When we make the root uh, left side root as right side, and here I am traversing the matrix grid. If the current ij is a land, then I will check the neighbors. If those are also lands, then I make the union find. I make them as union. So in here, the union will happen only when they belong to different sets. If they belong to same set, means we don't make the we don't decrease the lands count. So at the final we will be returning the count of lands. Now let us submit this. Line number 47. Okay, for the class we need to write semicolon at the end. Is valid. Okay, we have not written is valid. So here previously I have written this is valid condition. What this will do is it will check whether the given it will check the given indexes are in the range of the given grid. So now here I have not used calls. Here m is used. Here I have made a mistake. Here we need to pass direction. I have passed previously I and j, so that's my mistake. Now the code is working. Let us see whether this code is working for all the test cases, like a sample test cases. Sample test case is also passed, and I will submit. Previously I have submitted this using BFS and DFS. Now the code is accepted, and the time complexity of this is for passing checking like n into m using two loops for traversing, and this one is going to take of time complexity of 4, n into m into 4, and for a union it will be of time complexity of log n. So n into m into 4 into log n. So this will be the time complexity. I think when we use path compression and rank union, the time complexity will be more reduced. So that's why we got it as a 62%. Let us see the time complexity of union find algorithm with path compression and rank optimization. So let me time complexity. Of log. So the two techniques, the time complexity for each operation becomes smaller than O of log, and in it becomes small constant. So even though we have used this uh, yes, after using the rank union by rank and path compression, this is the searching will be become less than or is equal to O of log n. Like it will be of O of log n. Now the total time complexity that we have seen is n into m into 4 into log n log this log n will be of of n into m. So this much is a inner loops, like a inner part will contain, and this one is the two for loops that we have used. So that's it. If I made any mistakes, please correct me. So that's it.